Okay, today's notes are on vertical motion. So what we're going to be doing is we're going to be doing some quadratic applications, and the applications we're going to use are on vertical motion. So let me tell you what vertical motion is first. A projectile is an object that is propelled into the air but has no power to keep itself in the air. A thrown ball is a projectile, but an airplane is not. So an airplane can keep itself in the air, therefore it is not a projectile. So you can see here that this person with the hat is dropping a ball and he's throwing the ball up in the air and then it comes back down and then tossing it out with a little bit more of a curve here. So you can notice these are quadratic graphs here, but not this one because he is dropping it from a certain height instead of standing on the ground. So the height of the projectile is described by this vertical motion model, where t is time in seconds that the object has been in the air, and v is the initial vertical velocity in feet per second. And then we've got the initial height where it was thrown from. So what we're going to be doing in each one of these problems is we're going to be identifying a value for v, and we're going to be identifying a value for s in each problem in order for us to solve for either a height or that t in time. So let's identify what each one of these variables are first. What they stand. So 8 of t, this is our height. Jumped on me, back down. This is height in respect to time. T is our time in seconds. V is our initial velocity, and S would be our starting height. All right, so let's move this down here and put this into action with number 1. All right, so we're going to start by writing what the model is. So all I'm doing here is copying that model that was listed above. And then as we read this question, I'll show you where the pieces go. So a spindle in a gun air with an initial vertical velocity of 14 feet per second. So your initial vertical velocity is 14 feet per second. That goes right there. So this is your V. After how many seconds does it land on the ground? So we don't have a starting height. And that's because the armadillo jumps straight into the air from the ground. So if we don't have a starting height that's given, it started on the ground. So the height is 0. So let's substitute those values into this equation. So h of t is negative 16t squared plus 14t, so that 14 came from the information in the original problem, plus 0. And now what I'm looking for is when does it land on the ground again? So it's going to be coming up and then coming back down again. So it started on the ground at a height of 0. And I want to know when is it going back to a height of 0 again. So that means this ht, we're substituting in a 0 here. So that's the height at the end. So negative 16t squared plus 14t. So what we're going to do here is we're going to solve this. Since I don't have a constant, we have two parts that each have variables in here. I'm going to try and factor it. So if I factor this, if I take out a GCF, they both at least have a t, and then I'm going to take out a negative 2. So what they have in common is a negative 2t. So negative 16t squared divided by negative 2t will be a t. And then 14t divided by negative 2 will be negative 7. And then with zero product property, if both of these terms multiply together to give me 0, then either 2 negative 2t is 0 or 8t minus 7 is 0. So then I'm going to divide by negative 2 and I get 0. And then I'm going to add 7 and then divide by 8. And I have 7/8 seconds. I do a decimal on that because you're more likely to talk that way than to give me a fraction of time. Here are my two answers. And do they both make sense? Yes, because the armadillo was on the ground before it jumped, so that was 0. No time had passed yet, and it jumps into the air and lands on the ground 0.875 seconds later. So that is the answer to how many seconds does it land on the ground. Okay, looking at number 2, you're going to use that same equation, that same model. And then you're going to read the question. Soccer ball is kicked upward from the ground. So again, just like armadillo, starts on the ground, is kicked up, and then it's going to land back on the ground again. With an initial vertical velocity of 12 feet per second. So this is your V. And then it is kicked from the ground. So since this is kicked from the ground, it means that starting height is 0 again. So here is your V. And your starting height is 0, after how many seconds does the soccer ball land on the ground? So that means where is the height 0 again? So the soccer ball was picked up and then came back down again. So I want you to complete this model, and then I want you to put 0 in for each, just like we did on number 1, and solve that for me. So go ahead and pause the video, and then solve number 2, and then come back and check your answer. And then and if you land on the ground again, so we factor out pieces which set equals 0. So we got the t 0, which is starting on the ground. And then we got t is 3/4, so 7/5. Okay, moving on to number 3. We're going to write down our model again. And then we're going to read the question and take out the pieces of information to complete this model. A window washer drops a wet sponge from a height of 64 feet. So this is actually the starting height. After how many seconds does the sponge land on the ground? So if it lands on the ground, that means the height is 0. So this equation is going to look a little bit more like the very first model that's given, where instead of starting from the ground, they're starting from a height and then just dropping. So it's going to change slightly from numbers 1 and 2 because I don't have an initial vertical velocity. So there was no force that this was being thrown with. It was just being dropped. And that means that the initial vertical velocity is a 0. So my model here will be negative 16 t squared plus 0t plus a starting height of 64. So when will the sponge land on the ground? So when will we have a height of 0? Negative 16 t squared plus 64. Now here the fastest way to solve this would be to throw this out. Since I only have one and I'm having other variables. So if you subtract 64 from both sides, you'll have negative 64 and negative 16 t squared. And divide by negative 16, you'll get t squared is 4. Then you're going to take the root of both sides. And what you will get plus or minus 2. And since we're talking about time, how long will it take for us to get time? We can't use a negative answer. So we'll just say that that time is 2 seconds. Okay, let's move to the back. All right, we've got 5 parts to this same scenario with this athlete. An athlete throws a shot put with an initial vertical velocity of 40 feet per second. So again, let's click on our model here in the top so we can follow that. Negative 16 t squared plus v times t plus s. So an athlete throws a shot put with an initial vertical velocity of 40 feet per second. So I'm going to write that first. So that initial vertical velocity, 40 feet per second, is going to be 1 times t. The shot put is released from a height of 6.5 feet. So this is the starting height. So that's plus 6.5. All right, so the first question says, determine how long the shot put is in the air. What that really is saying is, when does it reach the ground? And when it's on the ground, it means the height is 0. So we're going to substitute in a 0 here. So negative 16 t squared plus 40t plus 6.5. So we have a quadratic equation here that is set equal to 0. And what I'm going to do is I'm going to use the quadratic formula. So I'm going to list my a, my b, and my c. My a is negative 16. My b is 40. And my c is 6.5. All right, so jumping into the quadratic formula, what we're solving for is time. So we're looking for c. So c equals negative 40 plus or minus 40 squared minus 4 times a times c, all divided by 2 times a. All right, so if we simplify what's underneath the square root, we've got negative 40 plus or minus 40 squared minus 4 is negative 16 times 6.5 in your calculator will be 2016 all over negative 32. So since we're talking about an application question, we're going to want to have a decimal answer here, just like we had some decimals on the front for our time. So we're going to simplify this even more, and you're going to need to use your calculator. So we're going to take negative 40 plus the square root of 2016 and divide that by negative 32. When you're doing this in your calculator, if you want to do this all at once, make sure you're putting that numerator in parentheses before you divide by negative 32. And what you get is negative 0.15 seconds, which doesn't make sense. You can't have a negative unit of time. So let's try the other option, which is negative 40 minus the square root of 2016 all over negative 32. And again, if you're putting this into your calculator, make sure you're using parentheses here. And what this one turns out to be is 2.65. So how long is the shot put in the air? It's in the air for 2.65 seconds. Okay, the next one. After how many seconds is the shot put at a height of 24? So in part A, what we did is we had a height of 0, so we substituted in 0 here for HC, or height with respect to time. So what we're going to do now is we're going to put in a height of 24. So we're going to use the same model, only now it's going to be 24 equals negative 16 t squared plus 40t plus 6.5. Now, in order to be able to solve this and to use the quadratic formula, we have to have it equal to 0. So we've got to subtract 24 from both sides in order to get this equal to 0. So if we do that, plus 40t, and then 6.5 minus 24 is going to be negative 17.5. And then just like part A, we're going to use the quadratic formula. So my A is negative 16, my B is 40, and my C is negative 17.5. Okay, so what I'd like you to do right now is I'd like you to pause the video and then solve for t, and you're going to similarly get two answers, and then we're going to figure out which one is the correct answer. Okay, so go ahead and pause the video and then unpause when you're done. Okay, so if you did this correctly, you should have two answers. You should have 0.57 this one, they're both positive. You why this one. So when it's wrong, it's coming up and back down again. So it's possible at two different times. On its way to maximum. And then 1.7, 1. So there is where it makes sense. Okay, next part. How many seconds is the shot put at a height of 35 feet? So this is height 35. So 35 is the height. And we're using the same equation. Squared plus 40t plus 6.5. So we're going to subtract 35 from both sides. We're going to have negative 16t squared plus 40t minus 28.5. So using the quadratic formula of this equation, we're going to have t equals negative 40 plus or minus 40 squared minus 4 times negative 16 times negative 28.5 all over 2 times negative 16. So t is negative 40 plus or minus, and we go to our calculator, 4 negative 16, we're going to get negative 224 all over negative 17. So you should notice that you have a negative right there underneath the square root. That means there's no real solution. So what that translates to is it's never going to be 35. So the shot put never reaches that height. Okay, so if we go back up to this diagram, B is asking us to actually find out what is the maximum. Maximum, so that's dy maximum height means that we're looking for the vertex. And so that is the way what we did is we took the x-coordinate of the vertex being the opposite of b over 2a. So going back to what our equation was, negative 16 squared minus 40, sorry, 40t plus 6.5 over a negative 16 and our p 40 is what we're going to be using. So to find that x-coordinate of the vertex, negative 40 over 2 times negative 16. So negative 40 over negative 32 is going to be 1.25. Okay, so that means that when this is coming up, this vertex right here is the time it takes to reach that height for the vertex. So we just found the x-coordinate, so that time means it takes 1.25 seconds to reach that maximum height. For us to figure out what that height is, we're going to take that time and substitute it in. So we're going to do 1.25 as our time substituted in. So we're going to square this. And when you're putting this into your calculator, you can type this in all at one time, including parentheses. And if you do that, you'll get 31.5 feet. So what that translates to on my little diagram is it takes 1.25 seconds to get to the 31.5 feet. Okay, so D and E is just taking the vertex and asking it as two separate questions. All right, let's carry on to our last question. A rocket carrying fireworks is launched from a hill 80 feet above the lake. So that's telling me a starting height with an initial vertical velocity of 64 feet per second. So that's V. So my equation here is h of t equals negative 16t squared plus 64t plus that starting height of 80. First question, what is the height of the rocket after 1.5 seconds? So that's time. So we're just going to substitute in 1.5 for t. And what we get is 140 feet. Okay, so that's the height of the rocket after 1.5 seconds. Part B says, what is the maximum height of the rocket? So again, when it's shooting up and then coming back down again, what we're looking for is that vertex. So just like number 4, D and E, we're going to find maximum height. But in order to do that, I first need to figure out what the x-coordinate of the vertex is. So I've got to do that opposite of B over 2a in order to know what to substitute in for t. Okay, so it's x, but really we're finding. So the opposite of b, so the opposite of 64 is negative 64 over 2 times a, which is negative 16. So negative 64 over negative 32 means it takes 2 seconds to get to that maximum height. We're going to take that 2 seconds and substitute it in order to find out what that maximum height is. So this is 2 squared plus 64 times 2 plus 80. And what we get here is a maximum height of 144 feet. What that means back here on the diagram is that at 2 seconds, the height is 144. Okay, so the maximum height is just the y coordinate of that person. All right, and then the last question in regards to this question, number 5 is, after how many seconds after it was launched will the rocket hit the lake? So hitting the lake is like hitting the ground. It means that we're looking for a height of 0. So 0 equals negative 16t squared plus 64t plus 80. You can actually factor this to make it a little bit easier to work with. I mean, if you went right to the quad formula, you would get the answer. You just have some larger numbers underneath your square root. But since I know that 16 goes into 64 and 80, I'm going to factor that out first. So if I factor out a negative 16, I'm left with t squared minus 4t. I have a positive 64 over a negative 16, so that's negative 4t minus a 5. Now, if you look just what you have inside the parentheses, you've got something that's pretty easy to factor. So leave the negative 16 outside, and we're looking at factors of negative 5 that add to negative 4. So that would be a negative 5 plus a 1. So since these are equal to 0, we're going to have t minus 5 is 0. So we're going to get t is 5 seconds. And then t plus 1 is 0. So t is negative 1. So I can't have a negative sign. So that means that just 5 seconds is my answer. So after how many seconds does it launch till the rocket hits the lake? Go back up to my little diagram here. It launched up at 2 seconds. It hits its highest point and then comes back down again, reaching the lake at 5 seconds. Okay, so that's vertical motion. Go ahead and go on to your homework now, and I hope you have a great day.